Hello and welcome to this webinar, Great Code Demands Great Security. This is part one, where we'll do the introduction and talk about securing your applications with automated testing. I'm Jonathan Jugenfors. I'm from OpenText. I'm a pre-sales consultant here for the Nordic region, and I'm passionate about AppSec. I'm one of the chapter leaders of the local OWASP chapters here in Jönköping. You can find me on Twitter at the handle Jugenfors. So just quickly about OpenText, I'm part of the Fortify team, and we were recently acquired by OpenText. OpenText is now a really big company with lots of different portfolios, not least in cybersecurity. We're now 25,000 colleagues here at OpenText, and we are a global company, and we have over 125,000 enterprise customers. Within the cybersecurity field, we have a large portfolio from ArcSight, Fortify, NetIQ, Voltage, and many others. And as I said before, I'm part of the Fortify team, which is the application security portfolio here at OpenText. So we have many applications today. Since we did our study in 2017, we've seen that the number of apps are increasing frequently, and also the market pressures on development teams and companies to make more frequent releases and get more features out there to customers. This, of course, is interesting for AppSec, because the more releases you have, the higher the chance that you release something with a critical vulnerability in it. And in this webinar, we will be talking about the first steps you will do in securing your applications, securing your APIs, and to give your company a good AppSec stance. There was a recent study by Verizon. They release new reports every year, but it was really interesting to see in the 2021 version of the report that many breaches are due to application security failures. If you can see in this graph here, of course, social engineering and phishing is the number one still. It's going to be for a long time. But almost 1 in 3 breaches are now due to basic web application attacks. So web app attacks are a major entry point for attackers. And in some cases, they result in data breaches, and in some cases, they result in ransomware and many bad things. So this shows you that applications are a major entry point for attackers, and securing your applications is a very good way of securing your whole IT infrastructure. Looking at some statistics here, we see a report from No Name Security that the average number of APIs an organization has in place today is about 15,000. That's a lot of API endpoints. And for big enterprises, this number might even go up to 25,000. It's a lot of attack surface to cover. And many of these APIs handle sensitive data and contain a lot of information that hackers really want to have. Looking further into the same report, we see that 41% of organizations had an API security incident in the last 12 months. Now, of these 41%, we see that 63% noted that the incident involved a data breach or data loss. Now, what that means behind the lines here is that they ran into deep trouble. So, for instance, GDPR, if you mishandle personal information of your customers, then you might run into large sanctions or even fines from government authorities. So you really don't want your applications and APIs to have these breaches, not just for your reputation, but also for your customer safety, and at the very least, so that you don't get fined by the government. We see a lot of challenges in application security today. First of all, it's hard to find good, talented developers that are trained in secure coding. It's even hard to find consultants and experts in AppSec. We have, as I said, a growing number of applications, a growing number of releases, and a growing number of attacks. The attackers always get better. They learn a lot of money from penetrating your networks. They want to find those hidden jewels that you have. We have rapid release cycles, faster go-to-market pressure, and marketing and customers demand new features. You want to get them out there. It's also compliance. Many different parts of the industry have specific requirements, but there's also the generic requirements. And as I mentioned before, GDPR. In the financial industry and card payments, you have the PCI DSS. And in the medical field, you have HIPAA and others. Then you also have a lot of outsourced third-party and open source code. Today, when you write applications, you don't write the whole application yourself, Most of it is actually used by third parties or made by third parties. Code that you include like libraries and components. And these components can also have security flaws. What if you find a vulnerability? How do you know you're using a specific version? We'll talk about that later. So when talking about AppSec, you cannot avoid the OWASP top 10. The OWASP project is a not-for-profit organization that focuses on web application security, and they continuously update their top 10 list of things that they find on the web. So these are the top 10 list of vulnerabilities like broken access control, injection, misconfiguration, authentication failure, security logging failures, and server-side request forgeries. These are the most common things that we see around the web today, and all of these lead to the major headaches for IT administrators and for security admins. Many people do misunderstand this top 10 list though. They say that, oh, we will be looking for these things and these things only. Okay, well, why do you do that? Because this is not a end all be all of everything that can happen. This is just a top 10 list. It's a taxonomy on what things you might be looking out for, but it's not a prescriptive list of what you should do when you write an application. This list does not tell your developers what to do and what not to do, but it's a good start. And I think we'll start this talk by talking through some of the common things we can find online. Let's go look at some recent and some not so recent events. There's a news here in Swedish from last year that says that Swedish Folkhälsomyndigheten, well, you can say it's our health authority that was also instrumental during the COVID pandemic. They were hacked, and they were hacked through a SQL injection, resulting in vaccine information about children being leaked. So good old SQL injections. We have had them for so many years, even decades. We have good tooling to find SQL injections, but yet they still appear in applications and hackers expose them. And even big, important organizations like Folkhälsomyndigheten are vulnerable to SQL injections. For some reason, they're still here to stay, although our tooling should be able to help such organizations to eliminate and find those things. So that's a major breach. There's also the LinkedIn breach, but what LinkedIn breach? There's many LinkedIn breaches. Well, in 2018, there was a breach from an insecure API. LinkedIn doesn't call it a breach because the API functioned as intended, they say. The problem was there was no rate limiting. You could just use this too much, and you could query the API for everything. You can ask for phone numbers and get data back. And then eventually someone could enumerate all of these IDs and be able to extract, I think it was like 92% of users, and their personal information was breached. This is obviously a data breach, though LinkedIn, they didn't see it this way. So 2 breaches or 2 hacks in the last few years tell you that application security is important for an organization. If you fail to protect your customers, then you will lose their customer data. You will jeopardize their security. Bad things can happen to them, but also your reputation is at risk. Do customers want to make business with you if you don't keep your data secure or the customer data secure? Probably not. And you don't want to be in the headlines. So let's go ahead and talk some more about how can we protect ourselves. So I want to give you sort of a roadmap of how you can improve your application security stance. I think the first thing is the most important one. I mean, if you don't know what you have, then you can't protect yourself. So if you have things on your network or applications that you expose that you don't even know you have, then there's no way of you putting in the adequate security measures. What applications, what APIs do you have? Who's the owner? Is there still an owner? Maybe you have legacy products that you don't even support anymore. You should turn those off. So inventory is always in the IT security, very important in order to find and enumerate every single attack surface, because only then can you start to make countermeasures. The next step is to do secure design, and I think design should be focusing on failing safe. You see in my picture here, we have the original patent of Otis for his elevator. And this was a major revolution because in his elevator design, it was fail safe. Even if this cable were to break, then there's automatic braking occurring in the actual cable car or in the actual car that you ride in, which means fail safe. If something were to happen, the car will stop. You won't fall down. Maybe you need someone to get you out of there. That might be tricky, but at least you won't fall down and get stuck or die from some fall injury. So whenever you start a new software project, or even if you have an existing legacy project, do threat modeling. What kind of risks do we actually have for this application and for this scope? What kind of data do we collect? Do risk analysis. What kind of risks are involved? And also try to limit the collection of data. We all know that personal information is a major headache and a major liability if you have an application. So try to limit what you're actually collecting. You don't need all the address information if you don't even use the address of a user. So don't ask user for it if you don't want to have it. So these two things are organizational steps, the inventory and secure design. This is what you start hopefully at the beginning of a software project so that you can take the adequate steps in the development process. Step 3, I would say, is tooling. Now we get into more technical details. One tool cannot do everything, but it can help you along the way to gain a lot of value. And there's security scanning and other tools we'll talk about here. The first term I want to teach you today is SAST. That's Static Application Security Testing. It's the test that looks into your source code. If you allow me to do a car analogy, that's when you take the drawing and the sketches of a car and have your tool analyze the sketch. SAST looks at your source code and does pattern matching, flow analysis, taint analysis, and so on in order to understand what happens in your code. It is good at finding some type of attacks. It is not good at finding holistic attacks, but for instance, injection attacks are quite commonly found with SAST. Since this is an inside-out testing, we can see exactly how data is flowing through your application. Exactly in what way do you talk to your SQL database, for instance. We go back to the example of SQL injections. So an example here is that we have some source code. This is some Java source code talking to the database. The SAST tool looks through it and it can tell you, okay, this query here, select star from customers where customer ID equals. And then we have the plus user ID. And this is called string concatenation, where we add strings together and then send this query to a database. And if there's no sanitization and we trust untrusted user input here to be in this user ID string variable, then an attacker can control what the database query will be. And they can start injecting some really bad things. As I said before, a SQL injection like this one was what caused the Swedish Folkhälsomyndigheten to lose a lot of information about vaccinated children. In a tool, say like our Fortify on-demand tool, a finding of SQL injection would look something like this. So we have our web interface, and it will tell you that in this example, line 71 of service.java, the method sort invokes a SQL query built with input that comes from an untrusted source. So again, the same thing here, but we have now this tool that found this for you. We can see both the explanation where it happened, but it also lists the source code saying, okay, so this part here is this plus column string that we add. If you then were to click to say a recommendations button here that we also have, then it would tell you a lot of things. But the best recommendation for SQL injection is to do query parameterization. So you have a list of parameters initialized in a very specific way that stops these variables to be modified in some untrusted way. So this is a web interface of a tool, but if you're a developer, you don't like to learn new tools. You don't like to have a separate account for your security testing. You don't want to think about this too much. Instead, we like to think of what the industry calls shifting left. This study from NIST a while back is the cost of finding an issue in different stages of the software development lifecycle. So we see it, we have the design requirements, coding, then we go to testing, system testing, and finally production. Now, why is this production number so high? Well, if you find a bug in production, that usually means you got hacked, right? So that's very expensive to finding a bug here in this later stage. Instead, tooling like Fortify can help you find bugs earlier. we can find things in the requirements and coding phase here. And the difference here between 5x and 30x, that's a lot of money in the cost. So finding things earlier is cheaper, not only because it's less work to do, but also that developers are still working on the same code base. If you give coders the feedback they need within minutes or hours or even days, then they can still have that fresh in mind. Compare this to finding a bug much later on, months later on, or even years. Then someone needs to be tasked with actually understanding the bug, going in and fix it, and trying to remember what they did a long time ago. So finding things early means you don't even have to involve your security team. You can have a tool like our IDE plugin, where the developer gets access to these findings straight back into, say, for instance, Visual Studio in this case. While they're still coding here, they write their nice code, they get the different vulnerabilities that we find straight into their IDE. So they can see that, okay, this method here, add user.click, has unvalidated data to the web browser, which results in something we call a cross-site scripting attack. Giving early feedback saves you a lot of money. The next tooling is called DAST, which means dynamic testing. SAST is something you should start with early, the static testing. You should start with that as soon as you write your first line of code. Scanning it early, finding any bugs quickly. Dynamic testing, on the other hand, requires the app to be running. So it can't be the first test you do, but you can start with it pretty early as soon as you have some kind of framework, some kind of mock-up of the application. DAST is outside-in testing compared to SAST's inside-out testing. So DAST will look at your application as it's running and do some kind of testing to it. Usually in the case of web apps, you do HTTP requests to it, simulating a browser, simulating a threat actor interacting with it. And DAST will by nature test your whole ecosystem. It doesn't specify a specific language. SAST needs to understand languages, but DAST is agnostic. So DAST tests the whole ecosystem, and it's actually pretty good at finding things like authentication issues. So SAST and DAST together are complementary tools, I would say. Starting with SAST first and then going to DAST a bit later, as soon as you have a running app, means you can scan early, find things early before things get too rigid and too fixed in your process. The next type of tooling is something that looks for third-party components. You probably all recognize now Log4j, which happened in December 2021. The Log4j vulnerability, called Log4Shell, was very major because Log4j is a very popular framework or library for logging inside Java. And Java, as we know, is everywhere. And this means that this very serious bug was in very, very many applications around the world. It looks something like this. An attacker could inject this kind of weird looking string with a $JNDI, LDAP, and so on with an IP address, and could start injecting code into running applications, which is really bad. Log4j was due to a vulnerable version of a library that was included, an open source library that many applications included. So we should start looking at not just our own first-party code, but also third-party components and seeing the versions. If you allow me to continue the car analogy, that's when we take a look at all the different components in your vehicle. What type of versions do we have for this component? Does the version have any known vulnerabilities? Can we upgrade this version to a newer version and get rid of these vulnerabilities? That's what a tool like software composition analysis can do. So SCA for short is something that checks your dependencies, checks your manifests, your software bill of materials, and helps you understand your risks and what you should do about the findings. As an example here, I have a Gradle application for Java. The build.gradle file lists a lot of components that we include. So you need a tool to understand a lot of these components because there's also sub-dependencies. These tools that I'm listing here, like the Spring framework, they are huge. They're big frameworks. They in turn include a lot of libraries. So you can have hundreds or thousands of components in your application, even though your first party code might just be 100 lines. Your actual attack surface is much bigger. So we have an integration with our software composition analysis tool that will list the known vulnerabilities and the known versions that you have in your application and how severe they are for you. It shows you the dependency and it tells you also how to upgrade. And in many cases, you can just do a one-click pull request, and then your application is going to be fixed in just a few clicks. That's pretty neat. But vulnerability is just one part of third-party components. There's also license compliance that we have. So open source tools often have very strict licensing. When you talk about something like copyleft, it means that if you include copyleft libraries in your code, that means that your code must be made public as well. In some cases, that's okay for you, but I guess for commercial applications, this is not really interesting. There was a car manufacturer a while ago that did include some third-party libraries. They didn't check the licensing, and in the end, they had to, for legal reasons, publish the entire source code for this car or for a specific subcomponent of the car. I think they did some malicious compliance though, and they technically did publish, but the license didn't actually require how it was published. So they sent like a pallet full of printed out pages where the source code was printed. They did technically comply to the license, but in the worst possible way. So a software composition analysis tool like ours will help you understand the licenses that you're also including. You can set policies to tell the application, hey, we don't want any strong copyleft license. We don't want any weak copyleft license. We want just our approved licenses that we can have, things that we can include safely in our source code without compromising the integrity or compromising the confidentiality of the code itself. If we were to look at all these tools we just talked about, SCA, SAST, and DAST, and where they fit into the application development lifecycle, then we can see that in the beginning, when you're starting the shift left, that's when you start using your SCA. An SCA tool can help you find the correct libraries to include, the correct components to have. SAST can scan from the first line of code that you write. You can scan during commit, you can scan on the build and every pull request and so on. Then your CI/CD pipeline kicks in, starts doing unit testing, integration testing. You have your code reviews, you have your staging environments, and then finally production. And as soon as the app can be set up again, then you can do DAST, dynamic testing. So again, you start the application in a safe environment, and then you start doing attack simulations onto it, and it can help you find like authentication bugs or ecosystem bugs or misconfigurations. Maybe you used the wrong SSL cipher or TLS cipher. DAST can help you find this. These are some thoughts about tooling that you can use. Obviously, there's many tools in the market. You don't even have to buy anything. You can also use open source tools that are great to use. I've used them in the past as a pen tester. Now, some of these open source tools, or most of them, are more of an expert level tool. It is great for an experienced security professional to use. They can really get a deep understanding. But for your needs, maybe you need something that's more automated, that integrates straight away with your build pipelines, with your CI/CD. If you're using GitHub, for instance, you want to have something that's just one click in the marketplace, you can add it. That's when a more commercial tool like Fortify would come in. But before we talk about the whole thing and the whole ecosystem, let me talk about step 4 of the application, because this is also important to secure your application and APIs. Penetration testing. This is where you basically hire an expert and outsource your testing to a person who knows their stuff. This is the best way to test your application in depth, and it will give you the best coverage. A manual test will use often tools also to improve the results. And this should always be done for sensitive applications, because tooling can only do so much. A human needs to do something as well. There's an obvious drawbacks with penetration testing. That is just the cost you need to bear. It is expensive. Consultants that know a lot about cybersecurity, they aren't cheap today, and they know they're cheap, and they know they aren't cheap. So yeah, you're gonna open your wallet. It's also quite slow, can't be automated, so you can't really put a pen tester in a CI/CD. Also, a pen test needs to be managed right. You can't just click a button that says pen testing and then wait for the results. You need to actually manage the team. You need to tell them the right scope. You need to give them, honestly, the right permission to find things in depth. We often run into something called a checkbox mentality, where compliance comes in, and a company just wants to follow the absolute minimum required for compliance reasons. Maybe a customer requires them to have like ISO certification or something similar. Then they're just looking for the checkbox to fill in. The problem there is that you can make your pen tests look like checking the box, but if you give them so small scope, then it doesn't really give any value to you. You just do it for compliance. Instead, try to make the pen tests as good as possible and as real as possible in order to find the real bugs. Now, the tooling that we have before, the SAST and DAST, that's really good to use together with pen testing, because then you can give your pen testers a good baseline, a good report of low-hanging fruit. So they don't need to spend their valuable time on really, really basic stuff. Instead, your tooling can help your developers find bugs early before they get to the security team. And then the security team can use the tooling to weed out all the low-hanging fruit before the pen testing and the expensive pen testers come in and do everything very deeply. I mentioned before that the OWASP top 10 lists are a really good starter, but they don't really tell you how to do things right. Instead, I want to focus your attention on the OWASP ASVS standard. And ASVS stands for Application Security Verification Standard. This is a prescriptive guide. This tells you exactly how to do things in a very detailed way. It's now in version 4. Version 5 is on the roadmap, so it's been through a lot of revisions. And there's a lot of stuff in the ASVS. Right now there's 286 controls spanning 14 verification topics. And they can look something like this. If you look at point 215, verify that users can't change their password. Check yes or no. Or verify that the password change functionality requires the user's current and new password. Check. So there's a lot of these things that are going to high level detail on what you actually need to look for in an app and make sure that you are implementing these things. And the ASVS also tells you here, bringing out a quote, we strongly encourage the use of security tools within the development process itself. DAST and SAST tools can be used continuously by the build pipeline to find easy to find security issues that should never be present. So ASVS tells you straight away, things that should not be present in your code are found by SAST and DAST. You shouldn't even consider those things because your tooling makes it so easy to find that your pen testers shouldn't even be able to worry about those things. So then, I mean, obviously I'm from Fortify. I want to tell you a bit about our Fortify tool as well. So Fortify On Demand is our cloud offering in which we leverage our Fortify platform in a very easy to set up managed service for you to use. We do all the things I mentioned today from the tooling side. We do software composition analysis. We do static testing, dynamic testing, and dynamic testing obviously includes API testing as well. But a nice thing that we have is also mobile testing. In mobile testing, then you can upload your mobile application. So we will check your mobile app for many of these vulnerabilities we talked about, and combining that with SAST or even DAST gives you a nice coverage of not just your web apps or APIs, but also your mobile apps. Because remember, your mobile apps contain a lot of data these days. So some key takeaways. Oh, by the way, I should say also, if you don't like cloud, we also have on-prem, and we will continue to invest in on-prem for the future. So we can give you the whole setup of different deployment models, both cloud and on-prem. So some key takeaways here from this call is that insecure applications can put your business at risk. And tools are nice to use, but they're not the magic bullet, but they will still bring you a lot of value. And an automated tool for SAST and DAST will make sure that every commit and every build and every version of your code doesn't contain these easy to find stupid bugs. So the 4 main steps we talked about today is inventory, where you look through what you actually have. Secure design, try to do threat modeling and risk analysis in the early stages of development. Then as you start coding, start doing security scanning, SAST early on and SCA early on, and then DAST when you're a little more along the way. And then finally, when your application is nearing some kind of release or important milestone, do penetration testing. And this should be done regularly, like once a year or twice a year. Often customers say, hey, this is a lot of work to do. How do we do this? Well, AppSec as a process for your organization, that is a long journey. But you can start every journey with a small step. So we see a lot of success for customers that have actually started their long journey with a small step a while back. And by continuously taking more and more steps forward, they did increase their security posture by a lot. So that's my webinar for today. And before we end, I want to mention the next 2 webinars that are coming up. We will be talking about open source based attacks in more depth. It's going to be on the 10th of March, and you can have either come to our offices in Testa in Stockholm, or you can do it also online. Then we'll also have in April, we will talk a bit more about API security, modern AppSec for modern apps, and how you can focus your security in the APIs. APIs are a bit different from AppSec in general and web applications. There's going to be a lot of things to talk about there. But Cecilia, do we have any more questions coming up?
Yeah, we have some question coming in here. And it's a little bit like, how easy can Fortify on demand be set up? And is it take its long time to do the implementation process? I know that you mentioned it, but it's a good to do a little bit clarification about it.
Sure. So an AppSec platform like Fortify, normally it does take some setup time, but since Fortify on demand is a cloud app, it's a managed service, then all you need to do is to acquire your tenant,
order.
and then after you order it, we have a managed team that will help you set it up, and the integrations are pretty easy to use. You can quickly get started by scanning your code. I wouldn't say it's a long process. It's normal tool you add to your CI/CD, and you can even start scanning manually before you set it up anything that's advanced.
I know that in our marketing things we say that within 24 hours you're up and running, and I think that is really the truth.
Yes, you can also start. You can also start small. You don't even have to do every single thing at once. I think it's important if you already have a lot of apps, don't do everything at once. Start small and focus on 1 or 2 important apps and start to do some SAST scanning on them. Try to get those fixed, and then you can implement more DAST and SCA as time moves on.
Yeah, great. And we have another question here also. How about something that highlights our strengths? What do you suggest to do? Fortify. What is the greatest thing with Fortify?
Yeah, so there's, as I said before, there's many tools on the market, not just open source, but other commercial tools. Some of the things I like about Fortify is that we have broad coverage of SCA, SAST, and DAST, which means that we have a unified taxonomy. If you find an issue, say SQL injection with SAST, we can find it with DAST. It's going to be the same name. It doesn't have different types of names and descriptions for it. We can actually unify the view for you as a customer, so you can understand the issues whether we find it through SAST or DAST. Also, we have a very broad coverage of languages. In SAST, we have like 30+ languages now, I think. It's continuously new ones being added on. Now with DAST, we support all these scenarios like authenticated scanning. We have even support for some multi-factor authentication, so we can do deep level scans and find things for you even if your app has MFA.
And one thing that I will add to that one again to really highlight that, start small. Choose 1 application or 2. You buy it as an asset unit, and it costs around 700-800 euro each for a scan. But that is something we always can discuss how the best way to do it. And I think that is a great thing to see, and get the awareness of what issue you have. Get that report scanning and start working from that one. Is there somebody else that have something to add to this one? Maria, Robin, Timo, Stefan, and somebody else. And I will just say thank you for this one. Hope you can join the next webinar that we will run in this series, because this is something that really is on top of the mind of the big companies and all companies today, because this question have raised a lot the latest year, and we want to be part of that with you. And you that is partner, there is a lot of information how to enable and do digital trainings, etc., that we have available for you. So if you have any question for that, please reach out to us at Open Text Nowadays. And my name is Cecilia Koch, and we work together with Arrow on this event. And please just reach out to us.